Ladies and gentlemen, please welcome Mr. Manuel Asali.
Thank you, Emma. Thank you, Michael. Ladies and gentlemen, good afternoon. I'm going to start by showing you a picture. I want you to see this picture in a different light. Think of it in the way the components that are making each of the different things you can see on the picture. Imagine those buildings. Try to picture yourself inside the building and look at the carpet on the floor or the paint on the wall. Look at those cars and picture the steering wheel, the dashboard, the tires. Look at the people on the street and imagine their clothes, their shoes, their breakfast. They have something in common, all of them. They are all touched by the petrochemical and polymer industry. Yes, ladies and gentlemen, this is our industry. This is what we do. We take oil and gas, we bring them into this box called petrochemicals and polymers, and on the other side, we make numerous materials that surround us in our daily lives. This will be our focus throughout this talk. But before I go any further, I need to explain something. I am a polymer guy, but I'm also a commodity guy. I'm not going to tell you about little specialty polymers that are sold for very specific applications in kilos. No, I'm going to tell you about the big commodity polymers, things like PET, polypropylene, polyethylene, PVC, some others. These are the ones that make up most of our industry. It's about 350 million tons of global demand. Now, these polymers have grown a lot over time. They are actually a success story. They have grown at about 3 times faster than global GDP for the last 50 years. And one of the ways they have been growing is by substitution. The combination of low cost, lightweight, and incredible flexibility has allowed us to use them to substitute other products, like glass, or paper, or metal, even other natural materials. It's sometimes fashionable to criticize polymers these days, but we forget that polymers also bring a great sustainability story. 100 years ago, we used to kill turtles to make combs. We have today substitutes for ivory. And our packaging allows food to last longer and to travel around the world. Now, polymers don't only substitute other products, they also substitute each other. And if you think of this as a pyramid, at the top we have the higher performance, at the bottom we have the lower price. And obviously this competition is going on all the time. I want to show you statistics of growth of demand in each of the major polymers. So take a look at polyethylene, high density, linear low density polyethylene, growing at about 4% per year annually. Low density polyethylene is a little bit more modest because it's substituted by its sister linear low. We have PVC growing at about 3.5%, still widely used in construction, for example. And then look at polypropylene. Polypropylene is one of the success stories too, because remember, polymers compete against each other, and this generates some winners, but also a few losers. Polypropylene is growing by about 6% globally. And it's finding new uses. I don't know if you're aware of this, but in some countries, we're making money out of polypropylene. This is an example from the United Kingdom. I actually have a sample right here. Today I live in London, and this is the money we use. It's made of polypropylene. Queen Elizabeth on one side, Jane Austen on the other. Now let's come back and see a few other polymers. If you think of polystyrene, well, polystyrene is flat. Polystyrene doesn't grow much because it's right in the middle of the sandwich. It doesn't have the performance to compete at the top. It doesn't have the low cost to compete at the bottom. And then look at the other big winner in this fight, PET, polyester. And this excludes fibers, but PET is the preferred material for packaging, for example, beverages and food. And it's growing by about 10% per year annually. This is the story. I went into statistics about the automotive industry, and I found that in 1960, we were putting about 10 kilos of polymers in cars. That number has grown today to about 150, 160 kilos. And after watching Gregory's presentation before me, I can imagine this line will probably continue to grow if we start using more polymers for some of those applications. So this is the story so far. Polymers have substituted other products, and they also substitute each other. But before I go on, I want to show you another photo. Can you tell me where that is? Well, the quick answer is actually, it could be anywhere. Sadly, there are many beaches that look like this, but this photo in particular was taken at Henderson Island in the middle of the South Pacific. Nobody lives in the Henderson Island, yet the beaches look like this. This, my friends, is a huge problem. Now, saying that polymers are bad is the wrong answer to the wrong question. In my opinion, the real question should be, how can we continue using these wonderful materials, but eliminating the risk and the problem in the environment? You see, our business model has always been linear. We make stuff, we push it through the system, and then it ends up somewhere. We recycle a very little bit of it, but the majority ends up in landfills or perhaps incinerated. But look at this, 30% of the polymers are actually leaked in the environment. This introduces then the concept of the circular economy. And I'm very grateful to the World Economic Forum and the Ellen MacArthur Foundation because they have popularized this image. The idea is that at the end of life, you don't just dispose of the material, but you find ways to bring it back. How can we do that? There are different ways. The famous 3 R's, reduce, reuse, and recycle. I'm sure you have heard of them. They are, as I say, a great idea, but they have implications and different issues. Let's go through them one by one. I have the 3 R's right there, and then I'm leaving another box at the bottom right corner that I just call other R's and 2 C's. You'll see what that means in a moment. Let's talk first about reduction, reducing. Our industry has been doing some of this for a while. We know about down gauging. Our films are becoming a lot thinner today. Lightweight. 20 years ago, a PET bottle weighed about 50 grams. Today, the same bottle will weigh about 18 or 19. But it's not only that, it's also regulation, maybe in the form of taxes. As I said, I live in the UK today, and in 2015, they implemented a charge on plastic bags in supermarkets. Many countries have done the same thing. Well, demand for plastic bags dropped by 85% in supermarkets. Right? But this is not only regulation itself, but it's also changes in customer or consumer behavior. Let's talk about the second R, reuse. And again, this is a point to make a clarification. Not all the polymers we make end up in the environment. They're not all single use. Did you know that 30% of the polymers we have ever made are still in use? We use them in construction, pipe, machinery, cars. Yes, these polymers are not used just for a few minutes. I know a plastic bag has an average lifespan of 15 minutes and then we throw it away. But when you think of a building, it can stand for decades. So let's just clarify the definitions. Not all polymers have the same dynamic. Anyway, those that do need to recycle or reuse can include other designs and uses. And I want to show you this picture. This is called Plastic Road. It's been implemented in the Netherlands as a test. They are taking recycled polymers and they make roads with it. The specifications of those roads can be such that they can have, for example, pipes under them, or it can help with drainage. And they can build them in a modular way. So that's a nice example of reuse. Now let's talk about recycling. Recycling is tricky. It requires 3 things to work at the same time. We need to have sufficient availability of recycled product. That's called guarantee of supply. We need to have demand that is happy to take that supply and will grow over time. And when that happens, that will prompt new investment in supply, which will in turn increase that supply in a virtuous cycle that grows over time. With some of the products we have talked already before, like glass, metals, paper, we have actually achieved that virtual cycle. Do you know how much of the glass is recycled in rich countries? It's about 1/3 of all the glass. When you look at metals, the number is bigger, is higher. Depends on the metal. Copper is lower, aluminum is higher, but the average is about 50%. This means of all the metals we use, we're recycling about half of them. Paper. We recycle 2/3 of all paper. These are all good numbers. How much plastics do we recycle, even in rich countries? The number is less than 10%. And the reason for that is because plastics have not been able to break that cycle. The raw material, the virgin material, is still incredibly cheap. And plastics haven't found that scale and that critical mass to really grow faster. Now, people are trying, let me tell you. Recycling needs to compete, and there are different types of recycling. So when you look at polymers, there's mechanical recycle. Take the polymers, chop them, and melt them again. This has been done by companies here in Europe like Ecoplast or QCP. And they will be, they're actually linking or joining forces with big polymer companies like LyondellBasell or Borealis. There's also chemical recycle. People are taking PET and breaking it back to its monomers, terephthalic acid, ethylene glycol, and making virgin polymer again. There's a company called Loop Industries, which is doing this. And they're all talking to people like Coca-Cola or Danone. Sabic is doing something interesting in their crackers in the Netherlands. They are taking polymers, they pyrolyze them, and then they mix them with vegetable oils and animal fats, and they feed that into their crackers. So they're still making virgin polyethylene and polypropylene, but it is coming from that renewable, recycled raw material, which I think is quite interesting. Energy recovery. You can just make fuels out of recycled plastics. And some companies are doing that. Recycling Technologies, Fulcrum Industries. Recycling Technologies is making naphtha out of recycled plastics. And Fulcrum is making syngas, which also can be used to make fuels. Recycling is a great idea, but there are 3 issues we need to consider. Number 1, it is by nature local and small. We don't want to move rubbish around. The capacities will tend to be, maybe in the best of cases, about 20,000, 30,000 tons per year. That compares versus a new plant making polyethylene, maybe 500,000 tons a year. A second implication of this is that they are higher cost. So the cost of the virgin material has to be balanced with the cost of recycling. And the only way we can break out of that loop is perhaps with some sort of carbon credit or some sort of tax advantage. Because remember, those recycled polymers already pay tax once. We shouldn't charge the tax a second time. Maybe there is a way in which we can help that break. And if we do that, recycling of polymers will grow maybe to 50, 60, 70%. And the third implication of this is that as this grows, some polymers will be preferred over others. We don't want to make many blends. We don't want to have polymers that have lots of additives and plasticizers, such as PVC. So who will be the winners, perhaps, in this recycling story? Well, again, our big polymers. Polyethylene, polypropylene, and PET. You see, PET recycles really well. You can take a plastic bottle and recycle it and make microfiber or polyester fibers. And eventually, you can even make carpets. So the same bottle can recycle really well all the way through. Just something to think about. I promised you my box with the other R's. So let's spend a little bit of time there. I'll mention them first, and then I'll explain a few. There's one called refuse, right? Don't call it reduce, call it refuse. Stop using polymers altogether. There's also renewable polymers, yes, which also have a few issues you will see in a minute. Redesign. I think this is an interesting one. If we can design polymers in a way that facilitates their reuse or their recycling, we can help create that virtuous loop. Branding. We don't do this on our own. Also, the big brands and the OEMs they have their own needs, and they're also pushing this process forward. And of course, we have regulation. Yes, I know these are variations of the 3 original R's, but I still want to call them or name them separately. They really are other R's, and they're still part of the story. But I have 2 more names, and they start with a C. The first one is called collection, and the second one is called cleaning. Let me go through some of these one by one. First of all, renewable polymers. To me personally, the idea of growing sugar in Brazil, making ethanol through fermentation, producing ethylene from that ethanol, and then making polyethylene and calling it green polyethylene, well, I'm not 100% convinced. If I throw that bag in the middle of the ocean, it's no different to any other bag coming from our normal petrochemicals. It's also more expensive. But still some companies are looking at it. Lego made an announcement a few months back. They said they're going to start using this renewable polyethylene. And the piece of news was interesting because it had a lot of information, and then right at the bottom it said something like, but it is not necessarily degradable. Of course, we know it isn't. And by the way, they're not substituting their typical blocks. Their blocks are made of ABS, and they cannot substitute that with renewables. They are only substituting the little trees, which are made of polyethylene, and it's about 1.5% of their total volume. And I'm not criticizing Lego, on the contrary. I think there's probably a different way to look at this. They're doing what they can because they are obviously under a lot of public scrutiny. It's a very public company, let's put it that way. Coca-Cola used to have its famous plant bottle. A few years back, they have toned that down a little bit, but they were also using ethylene glycol coming from the Brazilian ethylene, which it says, the label says, up to 30% made from plants. Again, I'm not really convinced, because this doesn't really solve the problem. Now, let's talk about brands. Yes, this is just an example from IKEA. They're saying they want to move away from single-use plastics. So, again, what I said, it's not only about us, it's also about our brands, which are going to be leading us in many ways and asking things from us as we go forward. Now, let me talk to you about regulation. And this is perhaps the most extreme case of regulation I've found. In Kenya, you can go to jail for 4 years and pay a fine of $40,000, up to $40,000, if you are using or distributing plastic bags. It's pretty strong, isn't it? Now, again, we need to put this into perspective. And let me tell you the way this works. The developed world and the developing world have very different problems. Or they have some differences. In the developed world, collection of plastics is not a problem. Actually, we recover most of the waste, including plastics. The problem in the developed world is in the sorting, the separation, because that's expensive. If you go to the developing world, the sorting is not a problem. Actually, in India, for example, lots of people make a living by separating polymers. But the problem is the collection systems. Sometimes they're very poor, sometimes they're non-existent. So if you are the Kenyan government and you have a big problem with plastics and you have no way to recover them, well then, they have the option to ban it from the origin point. You see? So if you put it into context, it tells a slightly different story. Which brings me to my first C, collection. According to the Helmholtz Science Institute in Germany, which was published by The Economist a few months back, I heard this statistic and it was staggering. Do you know that of all the plastics floating in the ocean, 90% of those plastics come from 10 rivers? 10 rivers that are located mostly in Asia, some of them in Africa, and a little bit in Latin America. If we want to solve the problem of plastics in the oceans, we need to start by helping some of those countries clean their act up. And this means helping Indonesia, the Philippines, the Mekong River in Southeast Asia. There's approximately 10 million tons of polymers that end up in the ocean every year. The Yangtze River in China is responsible for 1.5 million, only that river. 1.5 million tons of polymer. Can you imagine that? This is like building a world-scale cracker, which is of today a scale of 1.5 million tons, and you're just making polymers and dropping them into the ocean. It's the equivalent of that. So, again, institutions or different organizations are trying to help countries like Indonesia to solve this problem. That's where we need to start. Stop the leakage. And we can do some of the other things too. I wanted to show you this really interesting example because we also need to start cleaning up. And I don't know if anybody picked this up, but about a month ago, this came out, and they threw it into the ocean with a lot of fanfare out of San Francisco. It's a big contraption. It's about 600 meters long, and it's meant to be floating in the ocean and help gather polymers. It's very low energy. It actually is zero energy. It's just floating. But it's got all these sensors, and it naturally creates a sort of like a U. And it helps gather polymers, which can then be more easily collected and taken to the shore and recycled. So there's a lot of work going on everywhere. And this brings me to really this big question, or this big statement. This is a problem with many angles. The circular economy is a great idea. It's not necessarily easy. People are already doing it, but we still need to break some barriers and grow in scale. So these angles will include producers like us. But it also includes consumers, the end consumers, changing their behavior. It means talking to brands and OEMs and working together with them. We don't want them to make decisions on their own. We want to work together. And we want to maybe design things in a way that we can then recover and reuse, because there's a lot of hidden value in that recycle. It also involves governments and the education system and perhaps waste management companies. So if anything, I want to finish with a call to say, this is not only one thing, this is not a thing we need to ignore. This is not a thing we need to think we need to solve on our own. It's a multi-angled problem that has multi-solutions. Some will be local, some will work better than others in different places. But the thing is, we need to start making this happen. Thank you very much.